Got it. So when we talk about MapReduce, right, this framework is completely written in a language called Java. Okay, not that anyone have is asked or anyone is asked these days to write MapReduce programs, or why is it important. But understand that a lot of the things that we are doing here, the map, the reduce, all of this is very important in understanding any given um, uh, a distributed computing system, or distributed data processing frameworks like Spark, or uh, uh, any other distributed database or distributed OLAP system, right? That's why we are discussing this at great length, right? So now MapReduce, as I said earlier, is written in Java, right? This is written in Java. Okay. Every single program that we write utilizing MapReduce will be again written in Java. Not that this is needed in this current cloud data engineering setup, but this is really important detail to know, right? So why Java? Why not SQL? Why all of these questions? I will answer it along the session, but I just want to give some historical context. Up until this MapReduce, or the whole Hadoop ecosystem came in, everything was more or less written in SQL, right? And this is written in databases. This is written in data warehouses. Okay, data warehouses. This is written in MPPs, or massive parallel processing systems. All of this had SQL interface, but famously Hadoop or MapReduce just dropped it. Like they said, okay, we don't want to do SQL here. Okay, no SQL. We don't want to do any SQL here. They said, okay, Java, because SQL, for better or for worse, it has lot of drawbacks, right? We'll discuss when we discuss about SQL, or Spark SQL, all of this. But just say that for the sake of a brevity of our discussion right now, we will say that okay, SQL had lot of um, uh, inconsistencies, lot of um, APIs or functions in it. Every implementation of SQL in different databases had different their own way of doing things, and none of it didn't really like matter, or none of it really aligned with the standard ANSI SQL standard, right? So there was this issue with SQL being not a great abstraction. That's why people thought, okay, we will write everything in we will when the MapReduce thing came into light and everybody started using it, they will said, okay, we will write Java programs, okay, to express our business logic in it. Okay, Java programs, what do we do with Java programs? Express business logic in it. Okay, so that's the reason why we have MapReduce in Java. Any doubts on it? Now, since we discussed, or I barely mentioned about this, I've built a framework where you can you know, run MapReduce examples here and check the output for yourself. And even, like Spark, Hive, all of this in a single place. That is this basically this local Hadoop cluster. Now, since we have this one, a way to like run MapReduce programs, or see for how what they are, for what they are. I'll just explain what's going on here, right? So every MapReduce program, right, it consists of, since it's a Java application, it consists of a main Java file, right? That is word count.java. Word count is our example, right? Word count is our primary example that we are using with you know um, our MapReduce, right? Basically, this is like if you have text somewhere, what we want to do is we want to count how many words it has and how many counts each word has, right? So once we see here, what you are seeing here is that this is basically all the import statements, or we want to import um, all of the libraries in Java, or we want, right? Or these are called as classes in Java. Okay, these are called as classes in Java. Okay, right. So what are these? Basically, we have path, we have iterable text, all of this. We will discuss about this later, right? Now, every Java program starts with a class. So we have our application class as word count, right? Now, if you see here, this particular main one, it takes string args as a parameter. This is how a main function is defined in Java, that is public static void main. And it says that, okay, it throws an exception when there is an issue, right? If the arguments that we are passing to run this particular, class, right, or this object, that is less than 2, then we are saying, okay, we will quit it. We will quit this particular application itself, saying that, okay, we need both input and output paths. These input and output paths are basically your HDFS locations, where you want to read the data from an input path, and where you want to write the output, right? So we will see this in flesh in some time, but let me explain this. So if you want to start any Hadoop applications or any MapReduce application, right, this is how you start. Configuration, conf is the object name, and this is configuration. So what is this configuration basically? So this is to say that, okay, this is where my application or Hadoop application that is written in Java starts, right? And we have to define a job as well, right? We have to define a job as well, right? So this is basically how you are defining the job. There is a job class here. What we are saying is, okay, in the job class, we want to start a job where basically once the cluster has this, it will start our application task, whatever we are providing from this particular line, right? So this is the configuration. This is the job that we are defining for this particular job, right? So we are saying that this is my first class that you, as the Hadoop cluster, will start to execute, right? The job dot set, basically set jar by class. That means that this word count dot Java file, or word count dot class, that means this class. This is the starting point of our the whole application itself, right? So within this, a word count, what I'm referencing is, I am referencing a word count, a mapper class. One second. Yeah, a mapper class, a combiner class, and a reducer class. We discussed about what is a mapper, what is a combiner, and what is a reducer in our previous sessions, right? So we are defining them in separate files here, and we are saying that, okay, job, whatever you do first, once you are defined, okay, you will take this particular word count class as your main class, and that class will again refer, we will have, okay, we will say that, okay, within this class we are saying that, okay, this is my mapper, this is my combiner, this is my reducer. When you are executing the job, you will start with these three, right? Once we are done, what we will have is the output of this particular class, that is the word count class, is there will be some text, and within that we have a there will associating with it is an int variable. So that's what we want with a MapReduce, right? What we are doing with MapReduce is basically we will have some text, right? We will have some text here, so some amount of text that is written. So what we are doing is basically word comma 2, word 2 comma 5, all of these counts will be our final output. So that is what we are saying. For this particular job, that we have here, that we are defining here, we are saying that, okay, this is my mapper, this is my reducer, this is my combiner class, and the final output of this particular application will be in this format. That is some text, comma, int variable. Okay. So this is what we have, seen in our theoretical sessions as well, right? So this is the output, right? So what are we inputting here? This is the output, right? This is the output. Basically, whatever we are seeing, this is the output. This here is our input. Okay. This is our input. What are we inputting here? The source of the data, source path of the data, and the output path for our final output. So these are the two inputs that we are providing for this particular job, right? Once we are done with everything, right, it will wait for this completion, and once we are done with everything, this is where we exit the job, right? This is your basic Java program to understand what's going on with the MapReduce one. This is how people used to so this is how everyone used to write the MapReduce programs. Suppose you have 10 different mapper phases, right? Let's say to filter the data once, right? Suppose you don't want to have any bad data or bad words coming into your word count program or any cuss words, right? So we will filter them out. The next one. So that is one mapper phase. Suppose we want to remove all the words like is, as, all of this, right? Is, as, the, when, where, all of these, right? All of these English words. These are called as stop words, by the way, in NLP terms. So these stop words, we don't want this, right? We don't want them, in our final output. So we can use a map to clean up all of these words from our input itself. So we can create a map class, right? We can say that, okay, instead of just one map class, we can say n number of map classes. By the order of how we have to perform the operations, we can add different map classes here, and there will be only one reducer class, by the way. Unless you have multiple jobs, there will be for one job we will have one reducer class that will output the final output, right? Combiner we have discussed, right? The same logic that we have in reducer class, we will have in the combiner class, that will run parallelly along with the map reducer, mapper functions, right? So now let's look at the mapper class here. So what does mapper class do? Whatever the data that we are inputting, right? Let's say, you know, we are inputting, something like, what is it? Hello world, right? What mapper will do is hello, comma, 1, right? And world, comma, 1, right? Suppose the input is like, hi, this is money, and I am a data engineer. Okay. I like coding and music, right? Suppose this is my text. All of these words, like every single word that you are seeing here, right? Hi, this, money, every single word will get this output, like a 1 attached to it, right? This is the function of a map function here for the word count example, right? As you are seeing here in this one, we are creating a class. Again, we are extracting something called as a mapper object. This is a generic definition of mapper that we are importing from the Hadoop framework, right? Within Hadoop framework, we have MapReduce framework. We are importing that from the mapper function, right? So once we are this is basically saying that, okay, whatever that we are implementing in word count class, that is using functionality of the mapper that is already defined in the Hadoop framework. So for this particular one, what we are doing is, we will receive an object, we will receive a text, we will receive again a text, and we will receive and input 1. This is the, like input for this particular mapper, or this is the one that this particular mapper will, expect, right? So how are we dealing with this, right? So the first thing that we are doing is print final static int writable. What does this mean? Is static basically means that whatever you are doing in this program, right? This particular int writable one data will be accessible. It is not modifiable. And this is basically Java way of saying that, okay, I will declare a variable. Throughout this program, it is accessible and it will have the value of 1. Okay, whenever anywhere it is referred, right? It will give integer value of 1, right? So, and then the text is basically the word, the private text is basically our word, that is hello or, Hadoop or something like that. Any word that we are inputting for this particular one. So override is basically like this mapper object is basically a class, and within that we will have something called as a map function, right? We want to override the functionality and define our own function, right? So that's why we have this. The object is key, text is value, and then we are throwing in context. I'll explain what context is, right? This is very important one, by the way. What a context means, or what a context is, right? So what is context? Context is basically your task context, right? What do I mean by that? Suppose your job runs for 3 hours, right? This MapReduce job runs for 3 hours. And since this is distributed across cluster, right, of 3 or 4 machines, how does your master node or your task manager knows that this job is alive and running on all of these nodes, or completed or no? Some nodes failed on some nodes, whatever the state may be. How does this know? This is basically provided by your task context, right? Task context is basically in this particular distributed environment, whatever the task you have defined for the mapper or for the reducer or for combiner, or all of these different components, right? How well it is doing, and are there any failures? If there are any failures, how are we overcoming it? Or how is there any retries, or is the job like completely failed, or is there any resource crunch? All of this is like handled by this Hadoop MapReduce framework through context. All right, this is really important, by the way. Even Spark uses it. There is something called a Spark context, right? And we use it
Yeah,
in
thank
at
you.
least in vanilla versions of the Spark, which
Yeah,
is the open
thank
source
you, mate.
version of
Bye. Thank
Spark.
you, boss.
It will have Spark context. Sorry, somebody is speaking. Any doubt? Cool. Right. So this is what we want to. So once we start with the map process, right, we want to let this particular job master or job manager to know that, okay, I am processing this request of yours in the map phase to convert each word, along with, into a key value pair, that is the word, comma, count one, right? So what we are doing here is whatever the line of data that we are getting from the input path, when we are reading the file or when we are reading the location, we are storing that into a line, right? The value we are converting it into a string, and then we are converting into, we are each one, like each word in the sentence is basically converted into string, right? Into single word, right? What do I mean by that? Right. Here, if you check, right, we are getting, hello world, raw text. Okay. And this is not in your normal computer location. This is in your HDFS location, right? And HDFS location, as we famously know, this is stored in blocks of 128 MB, right? This is not full data, by the way, right? When we are getting the data, whatever that we are getting, so as we discussed, right, this is again the input is split before we receive it to map phase, and that is done by Hadoop framework itself. All of this is handled by Hadoop itself when we are saying that, okay, map, go read the data from this place, right? That's all abstracted from you. The distributed environment, the 128 MB, handling the block size, handling half split records, all of this is like taken care. We have discussed this in our previous sessions, right? Like here in one of our sessions, how does the record reader works? How does the record reader know what is the like like what is complete record or what is half record? How does it know? So all of this is, as we spoken earlier, right? This is handled by framework. We have like, I have like mentioned here, right? There are few phases here, stages in MapReduce. I am saying that, okay, this is handled by framework. This is handled by user, right? Shuffle phase again by framework. Again, a reduce phase, this is by user, right? So what do I mean by that, right? You're not seeing any input splitter, logic here. That means that your Hadoop framework itself, your MapReduce framework itself already has gone to the particular location, read the contents of the files, and it has split that input according to how this particular framework expects, right? So that is handled by your framework already. What your map does is where your business logic exists. Suppose we don't want to include cuss words, or suppose we don't want to use all the like bad words or malformed text. So all of this, that logic of how you want to see the output exists within this particular map object, right? Or your map function, or multiple functions, and that we can describe here, and we can use that in your map function, right? So this is what we mean by handled by user. So in this particular example of MapReduce, what we are doing here is that we are basically taking those lines of text and converting them into string first, and then using them in line object. And this line object we are doing is a string tokenizer. String tokenizer is basically like splitting your lines of text into words, right? Hello world will become hello comma world, right? Because hello is one word and world is one word. Suppose you have something like New York, you cannot say New and York. So this string tokenizer is aware of these kind of stuff, and it will split accordingly, right? So once we split, what we are doing is we are iterating on this object that has all of these words that are being split from your string, like your text, like full like lines of text. So for every single word, what we are doing is we are converting that to a into a text word, right? This word here is basically your a text, right? This is a text. What is a text here? This is basically like a class where it stores single word, right? Now, once we are done with that, what we are doing is we are saying that context dot write into world comma one. One is basically your integer one. That is here. This is the place where we write the yeah. This is the place where we write world comma one, right? That we discuss, right? For all the words that it will be done. What does this context do again? This context in this place will write this data to an intermediate storage, to intermediate disk disk storage, right? So what does it do, right? Why does it do this particular thing here? Why does it write? Because MapReduce was built at the time where hard disks, like spinning magnetic disks, were the norm, and it was not the RAM was not available that easily, and So they had to like store the intermediate results so that if there is any failure in the map phase, which itself takes hours and hours, hours and hours to run for some company like Google, which has like petabyte scale data sets, right? It takes really long time. So to avoid this issue, what they have done is, like let me just write the intermediate data to a disk so that I don't want to stop my processing of the data or job at hand. So that's the reason why this happened. So the next thing comes is a combiner, right? Sorry, what didn't you understand? Can you speak up? I'm sorry. Somebody texted me that they didn't understand the last sentence. What was that about? If you guys talking, you're talking on mute. Is it Jofi's? Cool. Uh, cool. I'm not able to like hear you if you're talking. You guys can hear me, right?
Yes, yes, yes.
Cool. Yeah. Cool. So now we are in combiner phase, right? What map does here is that let me just recap a bit. Map is basically like it will read your data and then it will just go ahead and do the parallel processing, right? Once we have all the words word comma one for all the words, right? There are there will be millions of records like this, right? If we send all of this millions of data to one particular like one particular like machine, like a reducer, it will crash out.
Please be on me.
What is that?
Hey Matt, who did that? Who did that? Who is doing those voices? Please stop. We are trying to learn, okay?
Okay, cool. Right. So now, since the map is like, sending a lot of data to one reducer, right? Or, like there will be hundreds of mappers in your job, by the way, right? If you have, a lot of data, there will be hundreds of mappers here. If every single mapper is sending, like tons of data at once to single reducer or just, couple of, reducers here, right? Just a couple of reducers here, and reducer count will be much 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 lesser than mappers. It will crash out. Like these will throw something called as OOM, or out of memory error, or out of memory exception, basically. Right? This is one of the famous exception in all of data, or distributed computing, basically data, distributed computing, basically, right? Saying that, okay, I don't have any memory, boss, I'm done, like I'm crashing out. So that's what it is all about, right? We don't want to do that. So what we want to do is, instead of just mappers and reducers, we will assign, for some operations only, right? We will assign, combiner, that works like in parallel to mappers, right? Basically, this is your mappers. Okay, this is your combiners, and this is your reducer, right? So combiners, what they will do is they will have same logic as your reducer, right? And then they will like calculate the. All right, I'm kicking out people that I don't know. Sorry, guys.
Hey, Matt, please don't kick me. I'm just trying to learn, please, Matt. I'm trying to learn, please.
Cool. Yeah. So now, since we know what a combiner does, combiner is basically like, doing what a reducer does, right? So if you check the like, logic here side by side, let me just put it this way. Right. If you see the, logic, it will be like, exactly the same. The logic would be exactly the same for both combiner and reducer. The only difference is that combiner works in tandem with mapper, right? As soon as the mapper is done, combiner will pick up the shuffled data from all of the like the whatever the map individual map data.
I
Within
like
the map,
watching videos of black men shaking their booty cheeks. I don't know why, but when I click on a video and see a
we're
black
done,
man
mate.
shaking his cheeks, it just makes my mouth.
Who is doing it? Who is playing this? Please
Hey,
stop.
you.
I'm telling you, stop, please. Please stop.
Right. Okay. So they both have same logic, right? So what happens with this particular, combiner is combiner works directly on your mapper phase itself, right? As soon as map generates any report, it will be returned to disk, and combiner will read those data, right? It will apply the logic of this particular, same reducer logic that we see with the reducer, and it will like you know it will simplify the data, or it will simplify the amount of data that is being sent. Let's just say your a mapper, the first mapper has hello repeated 100 times, right? Hello comma 1 repeated 100 times. The output of your reducer will be hello comma 100 at this mapper level itself, at this combiner level itself. That means that you're not repeating the same result for 100 times here, like hello comma 1 hello comma 1. You're just only sending hello comma 100, which is very less data compared to like tuples of hundreds of thousands of hello just repeating once. So it is not that memory intensive. That's why we use combiner logic. Can we use combiner logic for all of the data sets? I don't think so. Like all of the operations, I don't think so. No. Right. So we can only use for certain operations, right? Like sum. We can use it for max, min, all of these operations, right? Why? We cannot use it for averages unless we do it slightly differently. Okay, because if we calculate averages at the reducer phase, sorry, at the combiner phase, and again at the reducer phase, it is wrong. The calculation shift is wrong. Average on averages is not the right calculation. Okay, that's why we do it. That's why we don't do it. So what we can do is instead we can get the sum here, okay, and count, and finally in this one we can add, we can calculate average at once here at the reducer phase. Okay, this is basic basics, right? So if you check here, both the combiner as well as the reducer has same logic here, right? So what does this mean? Again, the reducer, again, the combiner, again, it will like do, it will import the reducer, class, and it will again, expect key and iterable, and that means your value, that is like in word comma one, right? And finally the context, right? It will sum up for every single value. It will sum up the value that it is getting for that particular key. So that's what it does. Any doubts here? Any doubts? Nothing? Cool. Okay. So this is one example. I would like to show you what it looks like in Flash, right? So this is my input, data that I'm providing for this particular MapReduce function, right? So hello, Hadoop MapReduce, hello world, MapReduce is powerful, Hadoop is framework, hello again. So this is my input text, very trivial nominal input text, right? So let me show you that. So on my name node, this is present in this particular user input, word count location, right? Give me a second. So this is the project that I've showed you earlier, right? The same thing. Give me a second. So this is the same thing. This is coming from, sorry, this is the same thing, right? That we have seen earlier. I have copied the data directly into the Hadoop cluster. Okay, just for our reference, and I've kept it here as well, whatever we are processing here. And let me see. Yeah, this is the one. Now we will run this particular, you know, um, example and check what's going on, right? This is not that. Yeah. So this is how you execute one, right? We are executing a jar file. Let me explain what it is, but let me show you. Before that, let me show you this. So basically, it is complaining that the word count folder already exists and it has some data, so it doesn't want to overwrite it, right? So let me just change the path. So here you are seeing some metrics being populated here for the job. So the total input files to process is one, number of splits is one, and splits basically is that blocks, right? So here we are seeing the status of the MapReduce job, and we don't see the output here, by the way. We don't see the output here, just the metrics of this particular one, right? So how many bytes it has read, how many bytes it has written, all of that, right? There are a lot of things that we can see here that is being done in the framework, right? How many inputs that that this map phase got, how many output of the map phase it has done, what is the output bytes, right? How does combiner worked, how many combine records the combiner outputted, reduce phase, how many final reduce happened, spilled record, shuffled maps, all of this data will be can be seen here for this particular map phase, right? For this particular map. So is that it? Like, is this the only way where we can see the job? No, actually there is something called resource manager here. I think it is 8080. So there will be URL that is present here. If you check here, that is this one, 8088, right? 8088. So this is basically your UI, for uh, you know your applications or your programs that are running in your Hadoop cluster. Basically, this is your resource manager where you negotiate resources for your applications that are running. Here you are seeing MapReduce as type. If you are running Hive applications, okay, it will say that application type as Hive. If it is Spark, it is Spark. What are the jobs that are that we are seeing here? All of this, right? So when it started, when it stopped, the application logs can be found here. If you click on this, whenever we are running anything, right? So all of the things that we are seeing on that particular place, we can see it here as well. Right. So this is how it is. This is how we are able to. I think it's not working, or maybe something is wrong with the setup. But yeah. So this is how we will be able to see how jobs are ready. So if you okay, anybody who had worked on MapReduce, right, or Hive or old school Hadoop systems, basically had something similar to this for checking whether their jobs went through, or whether they have any issues or something like that in the resource manager here. This is basically the cluster, right? This is how this is all the jobs that are this is basically cluster information, right? So that's how this is seen. Any doubts here? No? Yes? Thumbs up, thumbs down? No? Yes. Cool. Okay. So this is one example that we have discussed at length, and let me show you the output as well, right? So give me a second. So I've earlier shown the inputs, right? Input one. So we will see the output as well. So this is like, I've like ran multiple times. So when we have the data already present on HDFS location, the MapReduce will not overwrite it. So that's why I've created like multiple places. Right. So when we have the job status as success, we can see this, written in the file in the HDFS location as well. This is to let us know that the last run of this particular job is been successfully done. Right. There is nothing in that. Right. And if you want to check what's going on here, what's the output, we need to check, in this place. Cat is basically your concatenate command on Linux terminal. So we are using it on Hadoop cluster to just get the output out of our files and print it on the terminal basically. So Hadoop comes two times, hello comes three times, MapReduce comes two times, world one time, a again, all of these are one times, is two times, right? Are we seeing the same thing here as well? So hello comes three times, Hadoop comes two times, MapReduce two times, world one time, yeah, is two times, a one time, and framework once, right? So same thing, right? So this is how we execute, run, execute, and like work with Hadoop MapReduce. Can somebody tell why we have only one output file, and what is the meaning of this particular name here? Anyone? Take a guess. Cool. So this is because that we have only one reducer, right? The output of reducer file will start with, since this is a distributed cluster, we will have only part files as our outputs from one single machine. Since our data is small and we have only one executor that is working on this task, we have only one part file, right? Every single, like MapReduce job or Spark job will output part files. It will not output full output in single one file because no one single machine can handle all of the data. That's the reason. That's the simplest, reason, basically. A very crude reason. So when we are, outputting the, data through our reducer, the first, if you have only one reducer, right, it will start with this notation, basically, right? Part R 0. R means reducer. This is the number of the reducer's number. If we have two reducers and we have two output files, we'll have 0 0 and 0 1 at the end, right? Something like that. So this is to denote which reducer has outputted what data, right? So since we have only one reducer, we will have only one part file, and we can see all of the data here. Cool. Anything else, guys?
So is it that can one reducer give multiple output files?
No. One
Okay.
reducer, one file.
Yeah. Thank you.
Yeah. Cool. The essence of reduce operation is to bring down all of the data that is outputted from map phase into one single output. Since we have only one reducer attached in our system, that means that we have one single output at any given point. All right, cool. So I have a couple of more examples here. I'll share this link, GitHub link in some time. So I've put it in, advanced one. One is log analysis. How do you extract, IP addresses from this particular, data? That is one example. And there is one more, that is matrix multiplication, which is an interesting example. So basically we want to do a matrix multiplication for all of this one. This is very important and crucial step in any of the AI stuff that you read, like be it for image analysis, all of that. So any AI stuff is all matrix multiplication. So I have done all of this. So you can also how to run this framework, how we have to run have MapReduce one command, sorry, MapReduce jobs. All of this I have created documents here with help of AI again. So that is all provided here, how you can run all of this on your own system and do that. So that's all present here. You can check it anytime. So yeah, that's about it. I don't have anything else. If you have any doubts, please let me know, or else we can stop the recording for now. Cool. Great. Awesome.